Okay, this is the part I need to make here. So this came off of my Quincy QT5 compressor. I'd recently rebuilt it. In the process of doing that, I had a little problem with the cylinders, and I wind up having to take this on and off several times. And there's a ferrule. Every time you tighten it, it's hard to see on this one. You can kind of see it right there, yeah. See how it's kind of banded around there? You can see the material expanded around it. So after installing this several times, this little area here just got to the point where it was so distorted, the ferrule was cracked in the middle and it had stopped sealing down here on this end. I wound up having to cut it off, and I was like, well, I'll just buy a new one. So I called Quincy, and what Quincy told me was, well, you know, we'll sell you a 4-foot piece of copper and you could just make one. And I told him, well, can't you just send me the foreign part, because I don't form pipes. I don't really have the equipment to do it. And they said that there's so many configurations of those compressors, and like it's really a plumbing job, and usually, you know, they'll have a pipe bender just make whatever's required to fit. They didn't have enough configuration control over all the different models that are out there that they're able to sell me one that they could guarantee would fit. Quincy was trying to sell just a 4-foot piece of pipe. I think it was like 150, 200 bucks. And I'm like, come on. So I wind up going to onlinemetals.com. First time I ordered it was about, I want to say 38 bucks for a 3-foot piece. You know, they mail it right to your house. It's pretty straightforward. Got some of this and I tried to form it. You know, so what I did, have a steel cylinder that is about the diameter of this. So I welded it to a big steel table, and I welded a block back here, and I just tried to bend this over. What happens is, like when you bend it, you get like a stress load up here, and there's nothing to support the wall of pipe, and it just kinks and bends. I was imagining that it would work a lot easier than that, but turns out it's kind of complicated. So there's a couple ways that you could bend one of these pipes. One thing that people recommend, let me get this device out, I'll show you what it looks like. Okay, this spring device here, okay, this pipe's a little bit too distorted for me to get all the way on there, but it's on to about right there. But anyway, the idea is that you get hoop strength from the spring here, and so when you bend it, it pushes in on the sides of the pipe that are like where this bending is occurring, and it pushes that in and helps, you know, like keep the stress uniform so that the part will bend in the stretch direction that you're trying to turn it. But I tried this, I was not able to get it to work. I formed another one of these out of the 5/8 inch pipe, and I can't find it for some reason. I was looking around earlier just to show you what it looked like, but it got pretty close, right? But it wound up kinking like somewhere right here in the like the apex of this bend. And so I want to say there's probably a trick to getting these to work. Obviously they sell it and it's supposed to make it possible, but I was unsuccessful. And I mean, this pipe's expensive, and there's a limit to how much experimentation I want to do. So another thing that they tell you to do is you basically fill the pipe with sand and then compact it down. You can also put water in over the sand to help fill all the voids. Water is a non-compressible fluid. So the idea is that the pipe will be like full of non-compressible material. And so when you bend it, it'll try to maintain its cross-sectional area at all points, and so to avoid a restriction, because it would require, in order to do this, you're reducing the internal volume of the pipe, which would require the fluid to compress, and if it can't compress, it'll just maintain its diameter and stretch properly instead of just bend. So I did not try that. I'm sure it works. It seems like a lot to go through. Okay, I realized I was like about, I don't know, 150 bucks into this in terms of just experimentation on material, so I decided to buy a pipe bender. And probably never use it again, but it's in this box. I bought it from a company called Vevor. I have another one of their, it's like kind of a knockoff Chinesian brand where they take, you know, tools that are kind of expensive and figure out how to cheapen them up, and, you know, and make them overseas out of probably cheap materials to allow you to use a tool that otherwise would be probably unaffordable for like a one-off application. I also have this little bottle jack down here. It's a toe jack, and I use it to lift my machines. And for what it costs, I mean, I'm pretty happy with it, to be honest. I mean, there's nothing wrong with it. It does what it's supposed to do. So anyway, I gave them a shot. I've not gotten this out of the box yet, so I'm going to take this out and we'll take a look at it. Like I said, I'm like 3 tries into this, and so I'm really hoping this works. and save somebody some time. Got everything out of here. First thing I want to mention is packaging. This thing has like a little handle in both ends of the box. This one was ripped out. It looked like the mail company taped it back on. They use this thick honeycomb cardboard here, and so this is heavy. There's nothing inside of it stabilizing it, so I guess the idea is that this honeycomb is going to cushion the blow so it doesn't get knocked around too bad. I mean, it's all cast iron parts, probably fine for what it is. And then it comes in this little plastic bag with all the crap that goes in it. I'm going to go ahead and cut this open and we'll take a look. Okay, this is everything out of the box. There's this thick powder coat in here, and it looks like all the steel parts are have some kind of treatment to them. The U.S. imperial sizes and metric sizes are on here, so I guess the 25 millimeter, suspiciously close to a 1 inch, maybe it doesn't matter. Here's the 7/8. This is 3/4 here, number 19. Here's the 5/8 die. It's number 16. What is, I believe, is 9/16 maybe, number 14. 12 millimeter, 1/2 inch, and 10 millimeters 3/8. And then here's all the little rolling dies for it. This base, I guess it needs to get bolted down to something so that, you know, when you put the beans on it, it doesn't slip around. This gigantic handle, fairly thick wall, and this big, ridiculous plastic rubber handle there. I mean, some of it's kind of rashed up. Obviously, this came from China. It doesn't say on here, but I'm guessing somewhere over there. Who knows? Some of the paint is a little trash, but I mean, this is a tool, right? This is not something you're gonna put on display next to your Corvette. It's just function over form. I think mostly this powder coat is on here, you know, to keep the rust down. Let me set it up, and then we'll take it for a spin. Okay, I'm assuming what happens is it bolts down, the dies slip on like so, and then this, I think this needs to come off, this little die here, and then put on like whatever the appropriate size is. Okay, so for mine, I'm looking for number 16. Okay, so that goes in there. T-bolt goes back in. Sorry, I'm trying to do this with one hand, and I have pretty good manual dexterity, but it's tough to do while I'm holding the camera. Okay, so this is set up. I'm not gonna bend these two lugs together. I think this is the forces are just supposed to bear out on that fastener, and it doesn't need to be like clamped up. Okay, so then this nut here, I have this set up right here in this vise, and I have the 7/8 inch die in it, so I'm gonna try to form that pipe real quick just as practice to see how well it works out. I only have one piece of that 5/8 inch tube. So I got the right dies on here. It sets up like this. This part goes down. There's some adjustment you can make with this collar to move this die in and out. And I'm gonna try to get this tied against that pipe once I get it set in there. And then there's a screw on the bottom that needs to get tightened up so this thing's not like loosey-goosey in there. So let me go ahead and do that. I'll do it on camera. Okay, so I formed this beyond 90 degrees here. One of the things you'll notice is on the inside, there's not any kind of step that shows a shoulder. I mean, it's a very smooth transition, like a shepherd's hook. And on the outside, there is, I mean, I could see by looking at this, there's like a little bit of a width manipulation here and some truncation of the height on this dimension. But I mean, it looks pretty good, honestly. I think I'd be happy with that. It's nice and smooth, and so I'm not worried about, like, you know, any kind of wrinkle that could propagate into some kind of crack. It's nice and smooth. And so you can see how it kind of burnished the pipe. I think, yeah, you can see where the dye's marked off on it, though. I might put some lubrication on here. You can see there's a little bit of, like, burnishing of the material where the dyes made contact with it, but I'm really happy with that. And I mean, the amount of time I spent screwing around with this, and like I said, you know, this copper is not cheap, so the experimental factor can kind of get expensive. I think I spent right around maybe 110 bucks total to get this tool. So in my mind, equivalent value for what you pay. Honestly, I was looking to maybe take it somewhere and have somebody form this for me for a price, and they probably would have charged me, you know, at least 50 bucks to do it. I can see a little bit of a area transition right here. I mean, you're stretching this material, so you're gonna get some distortion, but I'm pretty happy with the outcome. One thing I noticed is there was a little bit of material transfer in between this dye and the pipe. I'm hoping like maybe a little bit of lubrication might do something to help that. So I'm gonna put some oil on this guy. And I found that other pipe I was talking about earlier. I previously tried to form this one, and I think this is kind of how it worked out. Like, it kinked really bad right here, and I wound up just bending it and breaking it. You can see these corners here. I think this is pretty typical. So I'm gonna try to form this radius again and see if I can flatten it out, and maybe try a couple bends on these parts just to see how it pans out. It's just a practice trial again. Snugging this dye up here. I'm gonna do it from the side here. Let me think, what's the best way to put some oil on a guy? Let me think about this for a second. There you go. Ah, okay. Okay. Remember this part was like already dickered. It was like bent in a couple places. But you could see here in this area, the pipe formed really well. There's no section reduction really. Like I said, this thing had already been like messed with. And so everything from here to about the area. You can see I even tried to heat this up before. You can see the coloration changes. Let me get in the light. You can see the changes where I put this on a torch and was using it to try to soften the metal up while I bent it. And anyway, it didn't work out. Tighten this bolt. Okay, move oil. Rub it into this dye on both sides. Oil on the top. Rub it on the pipe. Get some in here in the groove. All right, here we go. Okay, that's pretty flawless. There was a little bend in this side already, but you can see this straighten out pretty good here. So we're gonna try it again. Okay, one of the things I noticed with this is that there's a little bit of sag. I think it's because of the slop in this pin that goes through here. And so this thing under its own weight, you can see there's a little bit of slop in there, which allows the angle of this to hang down. And so it's causing a misalignment. And because you have this, like, you got that, it winds up producing that sharp edge here and a sharp edge here that's cutting into the pipe. So I'm gonna try to bias that towards the opposite direction and see if I can get it to come out better. Okay, here's what I need to do. I need to try to keep this pipe elevated so that it's not down at an angle. There's a little bit of slop in here, and so this thing has some rock to it, and maybe I could tighten this screw and get some of that out. It's all right here in this pin, so I need to keep this up, and then I'm gonna try to support this so that it's not either up or down, so this die tries to stay in the middle. Okay, here we go. Move. It's like pretty good. More hair. Well, okay. Looks pretty good. Okay, this is from this angle. I'm hoping I don't get in the way too much, but so what I'm doing here is I have this question mark is a little bit open. So I need to, so I bent this and it's going out like that, and I need to bend it back to 90 degrees. Okay, so you can look at this and this. So I need to bend it to about right here. Let's go. Oh, come on. Okay. I got a little bit more to go, I think. I can always like hand work it back a little bit if I need to. I'm gonna check how we did. It's pretty close to square. This is the old part. I kind of bent it up a little bit so it's like a little bit open, but you can see this radius here and here match. For the most part, pretty damn close. I guess the point is here though, is I tried a bunch of different methods to form this. This is like a double radius here. All the times that I tried before resulted in like waves and cracks. Is because this is on a compressor. I don't know, like I know the compressor is rated for like about 200 PSI. I don't know how much pressure is in the stand tube. It has to muscle through the already compressed air in the tank, and it may be significantly higher on the high pressure side of the compressor than the PSI of the tank. So I was worried about having some kind of like, these defects in here, because it could, obviously the load, everything's trying to push out at once, and these little crinkles. This one here is not that bad, but it could cause like a material strength reduction in that area. Would imagine that any kind of a rupture under that pressure could be dangerous. This bender that I bought here, it's a little quirky, and you gotta like work with it. Like I said, what I figured out is there's like a clearance distance that you need to maintain in between this die and this die. Otherwise, one will roll on the other, and for whatever reason, it makes it track up or down, and it was resulting in these little pinches where the roller itself was like rolling over the pipe. And so I loosened this up a little bit just so that when I swing this way, that the roller is not making contact with this die here. Also, there's a little bit of slop in this pin. I think this is just like lousy tolerance management at the factory. But you can see like this has a little bit of, there's quite a bit of a, maybe it's hard to see in the camera, but slop. And you can see what it does to this gap down here. You see how the die on this side is like much lower than the one on the top, because this little mechanism here is sagging. And so it kind of straightened out once the pipe got inserted. But in this situation where, maybe you're making contact with this die, or maybe your pipe's not perfectly straight, and it could start to like sort of go into like a shearing motion on the side of your pipe. So the way I managed that was I fiddled around with this and then did a couple tests and got it to work out pretty good. And then when I was bending, I was intentionally like trying to make sure that I was somewhere in between this position and this position, so that it was sort of in an intermediate state, and just, you know, followed the, we'll call it path of least resistance, so it didn't feel like I was cutting into anything. And then also I did it incrementally, and then kind of checked my progress to see if I was starting to cut in to the pipe, and then maybe I could back it out and like sort of correct things. But anyway, wound up turning out pretty good. I did not have any of that business on this guy. There is one little area here where the die was making contact, and it created like a little ring indentation right here. So I'm gonna blend that out, and I'm hoping it's fine. But I think what it is here on the end of the die, these guys here that hold them in, these are just rough. I think they probably use some kind of like a press that just pushes that material out of there, and it's sort of sharp. And so maybe you want to break these edges a little bit, and then it wouldn't hurt to put a radius on this corner here, and maybe some of these other surfaces where you feel something sharp, maybe round those over, just so that you don't have that like hard, sharp contact point. Yeah, I'm guessing it was caused by this. I could feel a burr on there all the way around on both sides. So anyway, something to think about. Okay, so the question is, first and foremost, does it work? Yes, it does work. I mean, these are my results from before. These are my results for forming on this thing. It works way better. I've tried several different things. I tried applying heat when I bent the pipe. I also put this like slinky on there to try to help, you know, keep the pipe area from reducing. This didn't do anything, man. In fact, I yielded the spring. And it's possible that there's a little bit of technique in there required to make these work that I just don't understand. Bottom line is, I couldn't get it to work. I'm not trying to become like a pipe bend master. I just want a tool that works right away. So is it worth it? Yeah, I mean, like I said, I probably used more material, more money in material, just trying to get some process to work than I did buying this thing that worked almost perfectly right out of the box. So, and I have quite a bit more pipe and stuff down here. Imagine there's a way you could modify this to get it to bend other things. So yeah, I mean, I'm happy with it. I feel like it was $100 well spent. This headache's over with, and I've had this compressor job going for months and months. And so having this thing form finally will enable me to move that project forward. Hopefully this helps somebody that's in the process of trying to bend tube. I mean, if you're doing plumbing, or if you're building like a, you know, like a moisture trap for your airlines or artwork or whatever. I mean, this tool here is pretty cheap and it works well. So I'm gonna go ahead and recommend it. Tool I'm gonna use by Nova. It's just got this little chamfer bit on here. It should work. There it goes. Gives it a little around the inside. And I'm just gonna hit this. I have a grinding wheel with a Scotch pad on it. I'm just gonna roll that around to get the one on the outside. And this ferrule just slides in over there. Just like that. Okay, sorry about the lighting in here. So this is my compressor, and so this is the pump. I completely rebuilt this guy, painted it, stripped it down, blah, blah, blah. And then there's this, I put a new valve in here, this check valve, and then there's this fitting here. So I'm gonna put some pipe dope on all these. I'm gonna use this guy in here, and then that copper pipe that I just made is going to fit in between, and I'll show you that. Okay, I got this little pipe connected here. Got it all that doped in. Tighten these ferrules up. Comes down here. I had to do a little trimming to get all this to fit up, but looks pretty good. So I need to complete the wiring. I got everything super tight on here, so I'm thinking it should hold up. But yeah, I'm pretty happy with the way this turned out. Let me take a step back here. There you go. You can kind of see what it does. So this is the low pressure side of the pump. It comes out here and goes back. That air is further compressed on the high pressure side, and then it comes down here and pushes it past this check valve into this tank and fills it up.